So we'll end week 8 by talking about how afferent feedback from exercising muscle will affect things. And really, we're talking specifically how it affects breathing or ventilation. So here are the 2 objectives or outcomes for today, or for this video. Now, before we exercise, your breathing starts to increase. What's happening is your motor areas are telling your cardiovascular and your respiratory centers, hey, I'm getting ready to do something. You might want to get ahead of this. We call this phenomenon central command. Okay, this is a positive feedback loop. In the moment when these swimmers are on the blocks here, they don't need more oxygen. But I guarantee you, every one of them, their heart rate and their ventilation is increased. Okay, they're getting further away from homeostasis. But this is because one part of the brain is talking to another part of the brain and trying to be prepared. All right. Now, muscles send afferent signals to the brain. And what is really interesting is that ventilation increases to the proportion of the frequency of the movement. And so what we've got here is we've got a couple of figures and so that I'm going to show you. And these are right out of your book. Now notice that here, let me pull my highlighter up. We've got a few variables. So we've got the load. Okay, we've got how much CO2 is being produced. We've got the ventilation, and then we've got RPM. Okay, the greater the RPM, just think more movement. Okay, but the load is constant. All right, so it doesn't matter how fast they're pedaling or how slow. Every minute they're pedaling, they're going essentially the same distance or producing the same amount of work. Well, notice what happens to ventilation when they increase RPM. So here they're going faster and slower and faster and slower. Well, look at this, breathing more and less and more and less. Okay, and so this shows that just by moving more, you're going to breathe more. Okay, the demand for oxygen is the same here. Okay, they're not producing or they're not needing more or less oxygen as they go throughout this. They're just changing the speed at which they're pedaling, and that's causing their ventilatory centers to breathe more. Okay, and so we can take that same thing, and now we've got this other one where we've again got speed and ventilation, and notice that here the load is changing. Okay, so that's what's up here, load. Okay, which is the same thing as down here. This blue line and this green line are the same. I don't know why they changed the colors. All right, so then we've got speed, that stayed red, and ventilation, well, that's yellow on this one, and then we've got CO2 production. So I guess they want to go the same color scheme. Okay, notice that when they kept the speed the same, the amount of RPMs, but they changed the workload, okay, the swings weren't as big and they were offset. Okay, so even though the demand increased, it seems that ventilation is really tied or strongly tied to the amount of movement. Now, obviously, if you increase oxygen demand, that's going to help as well. But just the act of moving is going to cause your ventilation to increase. So the last thing I want to show or talk to you about is a study by a guy that I've worked with. He works for the University of Utah these days. He's originally from Germany. He worked with my doctoral advisor at the University of Wisconsin-Madison. And he did a study 12 years ago, which is kind of nuts, in 2010. And what they did is they had subjects complete 2 exercise bouts on a bike, I believe. And in one bout, they were given a placebo, and in the other one, they were given fentanyl. Now, they gave them fentanyl to blockade or block the afferent information coming from the contracting muscle. Okay? And so other than that, everything was the exact same. So in one bout, everything was normal. In another one, they were basically preventing afferent feedback from the exercising legs. What they found was, even though the exercises were the exact same, someone with fentanyl had lower ventilation, higher CO2, lower oxygen, lower heart rate. Okay, it was like the brain didn't know exactly what was going on, didn't realize that they needed to breathe more, even though you had the movement like we talked about on the last time. Okay, so just the movement isn't enough, and just your brain knowing you're exercising isn't enough. It needs to get information back from the exercising muscle. So in other words, muscle feedback is important. So here are the 2 things I hope you can do. And we're done with week 8. We're on the back half of the semester.